we are back with the Ferrari 412 Resto mod today, and we are going to be talking about what's under this red cover, which is of course the front suspension. In the last few videos on this car, we showed you guys the design, manufacture, and installation of the rear suspension and the wide body rear flares that came with them. With the rear suspension done, it was time to move to the front of the car, which of course was going to be more challenging because the front suspension also has to deal with the steering. Now, of course, you guys may remember from previous episodes that we designed and manufactured the frame piece behind me to hold and support the new rack and pinion steering rack system for this car. We of course wanted to modernize the steering system and eliminate the reciprocating ball steering that the 412 came with. And now it was time to design and manufacture our front suspension system to go along with that new steering rack. So of course the first step to designing any good suspension system is to decide on the wheel and tire setup as well as the brake setup for the car. We decided early on that 18 inches was the biggest we wanted to go for wheel size, so we used Steve's personal Ferrari's wheel setup to measure and test the suspension system. And the new wheels that we designed and built would be built to the same exact specifications. You guys also may remember that we decided to use Ferrari 430 carbon ceramic brakes as our platform. With those things decided, we were able to move on to the design of the front suspension.
So what I actually did was I made just a test block to hold the caliper to the wheel bearing, and then we put the actual brake disc and the caliper and everything inside the wheel, and make sure that the models that we had on the computer reflected what was actually going on in real life. And then from that point, we then took the entire wheel, tire, brakes, caliper, and put it all into the car and held it with, you know, rudimentary like fixture exactly where we wanted it, and then measured it very, very carefully to figure out where it was relative to the forced suspension pickup point. Now that we know exactly where the wheel needs to be positioned in the car, now what I have to do is set about designing the rest of the suspension to hold the wheel where the wheel needs to be. The next important thing was to get the correct camber and the correct caster. The camber is going to determine tire wear and obviously very dependent upon how much body roll you have and a bunch of different other things. Given the fact that this was a GT car, we really wanted the car to have high-speed stability. Less emphasis should be put on low-speed corners and more emphasis should be put on it being a high-speed, stable, comfortable GT car. And so we came up with alignment specifications that were really similar to three vehicles: the Lamborghini Diablo, Lamborghini Murcielago, and the Jaguar XJ220. Martin and I knew that we were going to be making this entire suspension from the beginning. So given that we were doing that, we decided to add a few features that both of us really liked. So in our upright, I added two features. They're not completely unique to our upright, but there's certainly no Ferrari that I've ever seen that has it. One of those features being is that the actual taper seats, the seats that the tapers for the ball joints go into, are removable. I really like this idea because it vastly diminishes the amount of stress that's put on the actual aluminum upright. The second thing that we did that's actually kind of neat is I made a removable steering attachment point. So this taper here is where the rod end for the steering actually normally attaches to. And as you can see, that is literally able to be removed from the upright, and we can literally just make a different one. And in the case of this situation, we've made multiple different pieces that have different mounting points and tested to get the Ackerman exactly as we want and to get the steering angle as exactly as we want. In most suspension designs that I've seen, you have a lot of things that are like dangling around. So you need like ABS wires, you'll need brake lines, you need brake ducking. A lot of times when manufacturers and different people make suspension systems, they come up with clips and zip ties and different ways to hold all the wiring and all of the different things that are attached to the suspension on. So since I needed to be able to fixture this and hold this to CNC machine it and flip it over and machine the other side, what I did is I designed feature into the actual arm. So all these little holes are actually threaded. and that doubles, and it allows me to screw them to a plate and hold it onto a plate so that I can machine the opposite side pretty easily. So those threaded holes being on the suspension arms permanently allow us to have a large amount of different places that we can just attach and secure things. So any wiring that goes to the suspension, any other stuff that's in the suspension, we can just attach it to any one of those holes as we see fit. One of the really nice benefits about designing all of this in the computer SolidWorks wise is you're able to actually assemble everything together in an actual assembly and then move everything through its ranges of motion, which allows you to see where things would interfere with each other and where things would run into itself. And so as you can see here in this top arm, the shape actually has exactly the same angle as the actual angle of the shock, and so we're able to actually design all these into pieces together so that they're very, very well integrated with each other, and they all look purposely built for this project.
So now with the completed front suspension design, it was now time for Steve to move on to manufacturing each individual piece of the front suspension system. Wheel bearing is from a 370Z. I really like the fact that the 370Z bearing is a lower profile bearing, and as you can see here, when I get this out, it has the inner race on the back side of the flange. So what that means is one bearing is going to be here slightly above this flange, and the other bearing race is actually, row of balls is going to be inside the upright. Normally what I do with this is I put this bearing in and out by hand until I can feel how much resistance it takes to push the bearing in. At that point, then what I end up doing is because our anodizing has 4/10 of 1,000, so in other words it's 0.0004 to build it, a material is added by adding the anodizing. So what we do is I go ahead and I'll open it up with this end mill just a little bit more. With the machining work now complete, Steve and Martin set about assembling the suspension components to install the front suspension system.
About how tight you want it to be. Definitely nice and done.
Now we are getting the car side prepped. Again, we are going to be using these suspension forks that mount to the arms. These are factory, and we're going to be reusing these like we did in the back. So yesterday we got the front suspension test fit on both sides of the car, and today we're going to be working on the hardware side of things, getting all the hardware dialed in. So yesterday we sat down at McMaster Car and ordered a bunch of hardware for the car. So Martin's got everything pretty much set up on this side. We've got both of the hardware on the bottom here installed and tight, and we've got the shims put in the top. We're currently just using temporary shims. We will adjust this, of course, all as the car gets built down the line. But for now, he's kind of giving us an idea of our setup and how we're going to have camber and caster and all that. We can measure stuff, and soon we'll have the car fully on the ground. We've got the car on the ground. Martin has made temporary tie rods for the car, which you guys can see up in there. And what we're doing now is kind of just testing the steering, making sure everything is clearing. And right now, Martin is actually measuring the Ackerman with a kind of cool on-the-ground trick. I think we showed you guys this with the Maserati Bi-Turbo. So essentially what we're doing is measuring the angle difference in the steering from right to left at full lock. At this point, we noticed some undesirable geometries in the steering system that would need to be corrected. Martin and Steve did some reworking on the front suspension. We've now redone the testing here. We've successfully eliminated a lot of bump steer in the front suspension and also added Ackerman, which is really good. We're really excited where everything is coming out at this point. And now we're just gonna go fully set up the alignment, start working on the front fenders. When working to eliminate the bump steer, Steve and Martin took all three of the ball joints, both the tie rod ball joint, the upper ball joint, and the lower ball joint, into consideration. How those three interact with each other is really what determines a lot of how your steering works and how everything moves. Right now, when the steering moves up and down, we're seeing very little toe change, which is really nice for a high performance car. We don't want the toe to change really aggressively and give us a lot of bump steer. had one final piece left on the puzzle that was our front suspension, and this was the sway bar arm and link. We used a modified Speedway Engineering sway bar and sway bar arm and modified it to have 3 holes so that we could change the stiffness of the sway bar on the fly. So that is our completed front suspension system. We are super stoked with how everything came out. Super excited to drive this car and really see the massive difference in the suspension and the steering system in the front of the car. I think it's gonna make a world of difference from the original 412 stuff to this, and I am so excited to drive this car. I cannot wait. Thank you guys so much for watching this episode. If you guys made it to this part of the video, you are an absolute legend. Thank you so much for the support, and I'll see you guys next time. Peace.